Hey guys, let's do some math. So the last couple lessons were on the law of sines. This lesson's on the law of cosines, some more non-right triangle trigonometry stuff. So let me get my pen going. Not yet. This one's being a pain. All right, so law of cosines. First of all, let's just go into what the equations look like. So just like the law of sines, they are a useful set of equations to solve for stuff on non-right triangles. The triangles are labeled as we've been labeling them for the whole time. Capital ABCs are the angles, lowercase ABCs are the sides, and they're always across from each other. So you'll see that we have three versions of the law of cosines. They look pretty bad, but realistically, they're about one step on a calculator once you've rearranged stuff. If you're solving for little a, little b, little c, you use the appropriate equation. If you're solving for little a, you should have little b, little c, b, c, big A. If you don't, then this is not a law of cosines problem, or you're just not going in the right order. So notice how all these a, b, and c are squared. So realistically, you could throw that whole thing into your calculator and call it good. So just make sure you're in degree mode because you have a cosine going on there. And also that this b and that c are squared. Now, if you're solving for an angle, it's just, you can rearrange it a little bit, which I'll show you on one of these problems. So we use the law of cosines when it is a side angle side problem or a side side side. So the two versions that the law of sines does not work on. So let's try one of those. First one up is going to be a side side side. So solve the triangle, solve for all missing pieces, giving that information. So let me just make myself a triangle, label it. Let's see, A is the smaller, B is the biggest, C is the medium. So that means C, little c, B, big B, A, big A. So it doesn't really matter which angle I solve for first. They'll all work out the same. So let's do the A, and I'm going to show you how to rearrange the equation. So if I'm solving for big A, I'm going to use the equation that has big A. So A squared equals B squared plus C squared minus 2BC cosine A. Oops. Not C. O A. Hold on. Erase that weird thing too. Try that again. Cosine A. So I'm solving for A. So I'm just going to move everything to the other side and do an inverse cosine. So minus the B squared minus the C squared. Divide by negative 2BC. Oops. And then inverse cosine to cancel that out. And then it's just that formula. So I would say that the law of cosines is easier than law of sines so long as you have these varieties. So I'm going to type that in my calculator. So inverse cosine, make sure you put the top in parentheses. So a squared is going to be 8 squared minus 19 squared minus 14 squared divided by, and then parentheses, negative 2 times 19 times 14. And all one step on my calculator. I just have one line going on there. Hit enter. And I've got angle A. is 22.07. I'm just going to say 22 degrees. Okay, so one step on the calculator, just use the right formula. If I want to find b now, then I'm just going to do the same exact thing. So b squared equals a squared plus c squared minus 2ac cosine b. Move everything over, inverse cosine of b squared minus a squared minus c squared over negative 2ac. Now, notice it's pretty much the same as the other one, just a's, b's, and c's in different places. Okay, so I'm going to type that in again. Inverse cosine b squared is so 19 squared minus 8 squared minus 14 squared. Make sure you put the top in parentheses. I almost forgot to do that just now. Divided by negative 2 times 8 times 14. And I get an angle of 116.8, so I'm going to round it up to 117 degrees. Okay, and that looks like it makes sense. Okay, A is a very small acute angle. B I drew as an obtuse angle, 117 degrees. Now we could do the same thing for C, or we could just say C is 180 minus the two angles we just found. So 180 minus 117 minus 22, 41 degrees. So that's how to solve a side problem. And we also have side angle side. So let's talk about when law of cosines should be used. Now, when the law of sines doesn't work. So like I said, when you're given side or side angle side. Okay. So the other ones are law of sines. So law of sines is when you have angle side angle, angle side, and side angle, which is the one that might produce more than one solution. Side angle side is a law of cosines. Those would not work in law of sines. So the law of cosines always produces a single solution so long as it is an appropriate triangle. So if you produce an error, then it was an inappropriate triangle. If you're unsure what to use, law of sines, law of cosines, you could fill them all in and see which one works. But it shouldn't be too hard to see if you have side or side angle side. And that's law of cosines. Okay, so let's do another example. Solve the triangle for all missing pieces given the following information. So this one should be a side angle side problem. So A is 115 degrees. C is 10, B is 15. C and A. So this one is a side angle side, as you can see. So we have a side, we have an angle, we have a side, the angles between them. So I am going to solve for little a first. That's always the easiest thing. You turn it into a side, then do what we did in the last problem. So a is the square root of b squared plus c squared minus 2bc cosine big A. And that's all one step in the calculator. So let me actually write that out for you this time. I realize I didn't in the last one. So 15 squared plus 10 squared minus 2 times 15 times 10 cosine 115. So all that under the square root. So square root of 15 squared plus 10 squared minus 2 times 15 times 10 cosine 115. So I get A to be 21, we'll say 21.3 centimeters. Now, it's good to stop for a second and see if that makes sense. Okay, it should be the longest side since it's an obtuse angle, and it is. So 21.3 centimeters. If you're in radian mode, just to throw this out there, you probably shouldn't be by now because we only do degrees. But in radian mode, that same exact thing produces almost the same angle. It won't always, sometimes it will, sometimes it won't. So just be careful that you are in degree mode so you don't get too far off. Now, I need the two angles. I don't have two angles to solve for the third yet, so I still have to go ahead and do a law of cosines. I can do the B or the C. I'm just going to do the B since I have it right here. Inverse cosine B squared minus A squared times C squared. Inverse cosine B squared minus A squared minus C squared all over negative 2AC. And that's going to be 15 squared minus 21.3 squared minus 10 squared all over negative 2 times 21.3 times 10. And all that one step on the calculator. Putting the top in its own parentheses, bottom in its own parentheses. And I get 39.5, so let's say 40 degrees as my B. And now I've got two angles, solve for the third. 180 minus 115 minus 40 is 25 degrees. Whoops, 25 degrees. That was my other missing measurement. So at most, you got to do law of cosines twice on these, and then don't forget you can subtract from 180 to find a third missing angle. So I'm going to give you a few to try. See what you can do. Okay, don't solve them all, just try them a little bit. I've got the solutions here on the next slide that you can see what you did. Notice these are a mixture now. We have a side, which is law of cosines. We have a side, which is a law of cosines. We have a side angle, which is a law of sines. And we have an side angle, which is also a law of sines. So make sure you can identify what you're using, and we're going to go back and use those as well. So here's your solutions for those. Let me move my face out of the way here so you can see the bottom one. Oops, I don't know why it's doing that. Let me move it. There we go. So those are your answers. Try a couple of those. Make sure you know how to use law of sines and law of cosines. And that is it for the moment. Hope you guys are having a good 4th week of remote learning, staying safe, staying healthy. And I'll see you guys in the next one.